iSCSIDatastoreConcepts. Let's begin. In our journey so far through this course, we've identified a lot of really cool features regarding virtualization, including the fact that we can create a virtual machine where it thinks it has network adapters and video cards and hard disk drives, and all of that environment, everything that that virtual machine thinks it has been provided to it by the hypervisor. And in a vSphere environment, that hypervisor is the ESXi host or hosts. We also know that the hypervisor, the ESXi host, is using a set of files for the management and support of a virtual machine. And that would include, for example, the configuration file, the .vmx, and the disk file or files supporting that virtual machine, as well as any configuration and disk files that are used as part of snapshots. We also know that those files that support that virtual machine have to be stored somewhere. And that somewhere in a vSphere environment is in a container called a data store. And the ESXi host is the middleman. And when it comes to data stores, we have several options in a vSphere environment regarding where that data store is. For example, it could be directly connected, a hard drive that is directly connected to an ESXi host that the ESXi host has used, set up, and formatted with VMFS, and is now using that data store for the storage of virtual machine files. That is certainly one option, a directly connected hard drive directly connected to the ESXi host. And one of the challenges of directly connected storage, for example, let's say this is ESXi1, ESXi2, and ESXi3, and they all have a local data store directly connected. That directly connected storage is not shared between the ESXi hosts. That means if we have virtual machine A that we're currently running on ESX1, and for whatever reason, if we need to move that virtual machine and now have ESXi2 support it, ESXi2 doesn't have access to the local storage on ESX1. That local storage, that directly connected storage, by default is not shared between ESXi hosts. And we have a few solutions to overcome that challenge. One of them is to use network-based storage. For example, in our topology, if we had network-based storage, for example, right here hanging off of this dedicated storage network, how convenient is that? Then if we train ESXi1 and ESXi2 that this network-based storage exists, we can have them formatted appropriately so that we're using VMFS, that's the VM file system. And VMFS uses a block-based storage method. And there's also block-level locking on VMFS. And the benefit of that is that if ESXi1 is right in the middle of modifying some data on the disk, we want to avoid ESXi2 pulling that data in some kind of a half-baked state. So when working with network-based storage solutions, we really have several options, including iSCSI, fiber channel over Ethernet, and also if we're using NFS, we can use NAS. And in this nugget on iSCSIDatastoreConcepts, I'd like to focus on this option right here, using network-based storage using the iSCSI protocol. To implement an iSCSI-based solution, we need a few players involved. First of all, we need something called an iSCSI target. A target is a server or service that is providing the storage, the actual data store itself. So there's lots of vendors who can provide iSCSI targets. So let's imagine that we have this box right here that's from one of our vendors, and it's got several hard disks in it. It's network attached. They've got an IP address on this storage network. So the storage processor's IP address is reachable at 10.1.1.111. And as part of the configuration, we're going to either use an IQN, which is an iSCSI qualified name, and EUI can also be used, which is Extended Unique Identifier. And this storage appliance would be advertising or have available disk storage, and it would present that as LUNs. And LUNs is simply an acronym for Logical Unit Number. So maybe this storage appliance, for example, has 3 LUNs, LUN 0, and LUN 1, and LUN 2. So at this point, this storage appliance is sitting there, it's got the disk storage, it's all dressed up, and there's nowhere to go until somebody requests services of that storage appliance. So we can kind of think of this top half here as the server portion for network-based storage with iSCSI. And the initiator, the client if you will, is going to be our ESXi hosts. Now in order to communicate and work with iSCSI, we need an HBA, which is an acronym for a host bus adapter. It's a card effectively that needs to be inside of the ESXi hosts, which among other things would do a lot of the processing of the iSCSI commands as they go back and forth between the ESXi host and the storage appliance. It also could have connectivity to the storage network. that host bus adapter could. Now, one of the challenges is that not every ESXi host has a physical host bus adapter, but have no fear. We can emulate one in the ESXi host. We can create a virtual host bus adapter, and then what we can use is we can use a traditional Ethernet adapter, for example, this guy right here, to go ahead and connect to the storage network. And if we are going to use a Ethernet adapter, for example, a 10 gig or a 1 gig Ethernet adapter for that connectivity to the storage network, we're also going to be setting up some additional VM kernel port or ports for the purpose of networking. And for the iSCSI, this would be a dedicated VM kernel port that we would use to communicate back and forth between the ESXi host and the storage appliance. And very similar to the VM kernel port that has a layer 3 IP address associated with the existing VM kernel port for management, we're also going to have an IP address associated with the VM kernel port that we're going to use for storage. You'll also notice that this storage network is separate. We're not using the same network as the management network. We're not using the same network as our VM networks. We have a dedicated separate network just for storage. It is ideal if you can have a physically separate network. However, if you can't have a physically separate network, you should at least have a separate VLAN, which is a logical network, for your storage. We also want to make sure that when we deploy iSCSI, we want to make sure that the ESXi hosts, which are going to be acting as the initiators, and the iSCSI appliance, which is acting as the iSCSI target, we want to make sure that they are on the same IP subnet. No routing, 0, 0, 0. No routing between the ESXi hosts and the iSCSI appliance that they're working with. So in our lab environment, we have no problem. We have the ESXi host, which will be the initiators on the 10.1.1 subnet, and we also have our storage appliance, which is also going to be on the 10.1.1 subnet. So we're on the same network, and it's also a dedicated network just for storage. In this nugget, we've taken a look at a few concepts of network-based storage, specifically iSCSI-based storage, which includes targets, which are providing storage services, and initiators acting as clients who are going to use those storage services. We also identified that it's a great design idea to keep the clients and the servers, the initiators and the targets, on the same exact IP subnet, and when possible, have a dedicated physical network, and if not a dedicated physical network, then at least a dedicated VLAN just for your storage networking. Thanks for joining me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.